Hello viewers, welcome back to the channel DPC Smart. DPC Smart এ আপনাদের সবাইকে স্বাগত জানাই. In this video, I will start a new topic of MAKAUT B.TECH Physics syllabus, paper code PH-101 or 201, and the topic name is Quantum Mechanics. And before starting the video, if you have not still subscribed the channel, please do subscribe the channel and like the videos and share with others. And if you want to join my online class, then you can contact me through the WhatsApp number given in the background of my screen and also the other social media accounts given in the background of my screen. In the online classes, theory, numerical problems, previous year numerical problems and theory questions are solved and are discussed thoroughly for MAKAUT B.TECH Physics syllabus, paper code PH-101 or 201. So hurry to join online classes. So without wasting time, let's start the class. So this is the syllabus for quantum mechanics for MAKAUT B.TECH Physics, paper code PH-101 or 201. So it contains introduction to quantum mechanics, blackbody radiation, explanation using photon concept, Compton effect, de Broglie hypothesis, wave particle duality, verification of matter waves, uncertainty principle, Schrodinger wave equation, particle in box, quantum harmonic oscillator and hydrogen atom problem. So today I will start with introduction to quantum physics. Now to study quantum mechanics, we have to first know what are the backgrounds of these quantum mechanics or the quantum physics, or in other words, what is the origin of quantum mechanics? Why people started studying quantum mechanics or quantum physics? Now the word quantum, that means discrete. For example, quantum of energy, that means discreteness of energy, some small amount of energy which are discrete in nature and they are called quantum of energies. So in general, quantum means discrete. Now how this new field of physics, which is called quantum mechanics, evolved, or what is the origin of this, or background of the quantum mechanics or quantum physics. So during the end of 19th century, physics consisted of mainly three branches, which are classical mechanics, electromagnetism and thermodynamics. So these three branches were the only three branches of physics which people or scientists used to study. At that time, if any new physical phenomena were observed, they were solved by the help of only these three branches, which are classical mechanics, thermodynamics and electromagnetism, until a new field or new branch of physics evolved. And those new branches or new domains or fields of physics were relativistic domain and secondly microscopic domain. তার মানেটা কি, 19th সেঞ্চুরি যখন যে কোনো ফিজিক্যাল ফেনোমেনন নেচারে দেখা যেত, সায়েন্টিস্ট ট্রাই করতেন কি টু সলভ ইট ইউজিং থ্রি ব্রাঞ্চেস অফ ফিজিক্স, যে তিনটে ব্রাঞ্চ তখন মোস্টলি পপুলার ছিল। তারা কি কি, একটা হচ্ছে থার্মোডাইনামিক্স, সেকেন্ড হচ্ছে ইলেকট্রোম্যাগনেটিজম অ্যান্ড থার্ডলি হচ্ছে ক্লাসিক্যাল মেকানিক্স অর নিউটনিয়ান মেকানিক্স। তো যে কোনো নিউলি ইভলভ ফিজিক্যাল ফেনোমেনাকে এই তিনটে ব্রাঞ্চ দিয়ে সলভ করার চেষ্টা করতেন সায়েন্টিস্টরা। বাট যতক্ষণ পর্যন্ত না দুটো নতুন ব্রাঞ্চ ফিজিক্সে এলো, তার মধ্যে একটা হলো রিলেটিভিস্টিক ডোমেন অর রিলেটিভিস্টিক ফিল্ড অ্যান্ড সেকেন্ড হলো মাইক্রোস্কোপিক ডোমেন, মানে মাইক্রোস্কোপিক ফিল্ডের যে কোনো অবজারভেশন। এই দুটো নতুন ডোমেন যতক্ষণ পর্যন্ত না এলো ততক্ষণ পর্যন্ত পিপল ইউজ টু সলভ এভরিথিং ইউজিং দোজ থ্রি ব্রাঞ্চেস। But when these two new branches evolved in physics, they were unable to solve it using classical mechanics, thermodynamics and electromagnetic theory or electromagnetism. So the two new domains were relativistic domain and microscopic domain. Now what is relativistic field? Year 1905, Einstein gave the theory of relativity. But it was seen that this theory of relativity has some limitations on validity of Newtonian mechanics when the speed of the object becomes comparable to the speed of light in free space. So when the speed of the object becomes comparable to the speed of light in free space, then the theory of relativity given by Einstein based on the Newtonian mechanics that failed or ceased. And the second domain, which is microscopic domain, that means phenomenon in the subatomic level or microscopic level. So phenomenon in microscopic domain. as soon as new experimental techniques were evolved, the classical physics could not explain all those new experimental phenomena. So, for example, black body radiation, secondly, photoelectric effect, and thirdly, phenomenon in the or incidents in subatomic level, means the particles within the atoms present, their motion or their phenomenon could not be explained by the help of classical physics or Newtonian mechanics. So, phenomenon in subatomic levels. So, all these things could not be explained with the help of Newtonian mechanics or thermodynamics or electromagnetism. So, by classical approach, these two domains could not be explained. Then in 1900, Max Planck introduced a concept of quantum of energy. So, who introduced concept of quantum energy or quantum mechanics? The answer is Max Planck. So, Max Planck introduced concept of quantum or quantum of energy. So, he considered that energy exchange between radiation and matter would be in discrete manner. তার মানে কি, এনার্জির এক্সচেঞ্জ যদি হয় একটা রেডিয়েশন এবং ম্যাটারের মধ্যে, তো সেটা কখনোই কন্টিনিউয়াস হবে না, সেটা ডিসক্রিট ম্যানারে হবে। দ্যাট মিন্স discrete amount of energies will only be exchange between them. যে কোনো অ্যামাউন্টের এনার্জি দুজনের মধ্যে এক্সচেঞ্জ হবে না, অনলি সাম কোয়ান্টাম অফ এনার্জি বা সাম পার্টিকুলার ডিসক্রিট অ্যামাউন্ট অফ এনার্জি দুটো রেডিয়েশন এবং ম্যাটারের মধ্যে এক্সচেঞ্জ হবে। So this concept Max Planck introduced to explain black body radiation or in quantum mechanics. Now, for example, suppose energy exchange between an electromagnetic radiation and surroundings which consist of matters. So, energy exchange between EM radiation and its surroundings, if we consider, then suppose the frequency of electromagnetic radiation be nu, then the energy exchange which will occur in discrete manner between these electromagnetic radiation and its surroundings would be only integral multiple of this energy, that means n into h nu, where h nu is the corresponding energy for frequency nu and where h is called Planck constant, and here n is an integer. So, energy exchange between electromagnetic radiation and its surrounding having frequency nu would be only n integral multiple of h nu, where h nu, this energy, is called quantum of energy. So, here energy exchange occurs in a discrete manner, which is the concept of Planck. Now, to understand quantum mechanics or to discuss quantum mechanics according to the MAKAUT B.TECH physics syllabus, we have to know some relativistic approach or relativistic concept. So, I will discuss few of the relativistic concept or approach that I or you need to study quantum mechanics syllabus according to MAKAUT B.TECH physics syllabus. The first concept I will discuss here, which is dependence of mass on velocity. So, till date, whatever you have learned previously, that in Newtonian mechanics, mass is constant in every reference frame. According to Newtonian classical mechanics, you have learned till date, means mass কখনো different system এ, মানে পৃথিবীতে যা হবে চাঁদেও তাই হবে, মঙ্গলেও তাই হবে, that means mass will be same. But according to relativistic concept, this is not true. So, according to theory of relativity, if an object or a reference frame moves with a velocity which is comparable to the velocity of light, then its mass will not be same in every reference frame. So, its mass will change. To explain this, let us consider two reference frames. One is S frame, this one is S frame, which have three coordinate axes, OX, OY and OZ. This is OX, this is OZ and this one is OY suppose, and this is the origin for the frame S. And let us consider another frame of reference which is S prime frame, and whose axes are OY prime, OX prime and OZ prime. And this S prime frame is moving with a velocity u with respect to S frame. So S prime frame is an inertial frame moving with respect to another inertial frame with velocity u. মানে কি S prime ফ্রেমটা S ফ্রেমের রেসপেক্টে একটা velocity u নিয়ে মুভ করছে. And let us consider an object which has a mass of m naught, or rather we can say it rest mass m naught with respect to S prime frame, and it is present in S prime frame at rest. So m0 is the mass of or rest mass of object in rest frame or S prime frame. S prime frame এর রেসপেক্টে m naught mass হচ্ছে at rest এ আছে, but S frame এর রেসপেক্টে m naught mass টা রেস্টে নেই, because S prime frame is moving with a velocity u with respect to S frame. তার মানে m naught mass টা S prime frame এর S prime frame এ রেস্টে আছে, তার জন্য রেস্ট মাস হচ্ছে m naught. Suppose u, the velocity of S prime frame which is u is comparable to the velocity of light in free space. তাহলে কি হবে? The observer in S frame, if he measures or he or she measures the mass m naught, then he will get a different mass value of m naught, as the velocity of the second reference frame S prime is moving with a velocity u with respect to S, which is also comparable to the speed of light or velocity of light in free space. So the mass of the object with respect to S frame would be, so mass of object with respect to S frame would be given by this relation, m equals to m naught divided by root under 1 minus u square by c square. So this is the relation or of relativistic mass measured in a reference frame S. So this would be the relativistic mass measured in S frame. What we get? The mass of an object in rest frame and which is moving with and that frame is moving with a velocity with respect to another frame. Then from another frame, if someone measures the mass, that will be different from m naught, and that will be given by that equation as I have discussed previously. Now if we plot m versus velocity graph using this relation, we will get this kind of graph. So if we plot m along y-axis and velocity along x-axis, then we will get this type of graph. So this is the corresponding graph. So when velocity is 0, that means if u value is 0, when u 0, then m becomes m naught. So mass will be the same as the rest mass. So this is the m naught value. This point is m naught, and whenever you velocity reaches to speed of light, then what will happen? This will be u by c square, u square by c square will be 1, almost 1. So m would be tending to infinity. So that's why it is tending to infinity whenever it approaches the value of c. So this is the nature of the m versus or relativistic mass versus velocity graph. Next we will discuss about mass energy equivalence, or rather, as we all know, E equals to mc square relation. Suppose an object is at rest and an external force is applied to the object to increase its velocity from 0 to a certain velocity, suppose u. Now, the kinetic energy would be equals to the work done by the external force on the object to increase its velocity from 0 to u. So, what would be the source of kinetic energy gained by that object? That would be equals to work done by the external force or applied force. So, the kinetic energy, if we denote it as T, then T would be integration of dt starting from, or which would be equals to dt. Integration of dt means the source is work done, that means f dx. So, it would be 0 to x. When u was 0, x was 0 and u becomes, suppose u is the final velocity, then u becomes u when x equals to x. So, what we get? dt equals to f dx. Again, what is f? Change in momentum, rate of change in momentum. So, d mv or mu, where d mu divided by dt into dx, which we can write as d of mu. So, dx by dt, we can interchange it, which would be equals to, here m is the relativistic mass. So, m is here relativistic mass, not rest mass. So, here we can write, so mass m is not constant here, relativistic mass. So, here it would be m du plus u dm into dx dt means u. So, this one is u. So, finally we can write m u du plus u square dm. So, dt we get mu du plus u square dm. So, this is dt. We give one equation name, suppose 1. Now, relativistic mass m is what? M naught divided by root under 1 minus u square by c square, as we have discussed just earlier. Or if we square both sides, we will get m square, and if we multiply this denominator with m square, then we will get m square into 1 minus u square by c square, which would be equals to m naught square. Or next line we can write as m square c square minus m square u square equals to m0 square. So, from here we will get, if we take partial differentiation, d of this term left hand side, m square is c square minus m square u square, which would be equals to d of constant term, which would be 0. So, from here we will get 2m c square dm minus of 2m u square dm minus 2m square u du equals to 0. We can take this term in the same side and other term right hand, and we take common 2mu, then we will get u dm plus m du, which would be equals to 2m c square dm, this term. So, this will cancel out, 2 m will also cancel out. So, we get u square dm plus mu du. So, u square dm plus mu du equals to c square dm, and we take or we name it as equation number 2. So, from equation 1, what you got? This was the equation 1. So dt was mu du plus u square dm. And from equation 2 we got u square dm plus mu du is c square dm. So from 1 and 2 we get dt equals to c square dm. From equation 1 and 2 we get dt equals to c square dm. Now to get t we have to integrate dt, and integration limit would be, and which would be equals to c square integration dm, and integration limit would be m0 or m0 to m, that means rest mass to relativistic mass m, or we get t equals to c square m minus m0, that means mc square minus m0 c square. So kinetic energy becomes total energy mc square minus rest mass energy. So which is equals to, so again kinetic energy would be c square into this one if we take change in or increase in mass due to motion. So that is increase in mass due to motion. Now this one is kinetic energy. So kinetic energy is total energy minus rest mass energy. So the total energy E would be equals to kinetic energy plus rest mass energy. So kinetic energy is T plus rest mass energy is m0 c square. Now T value is this one. Total energy would be this plus m0 c square, means mc square minus m0 c square plus or m0 c square. So this will cancel out, and total energy E would be what? mc square, which is the Einstein's mass energy equivalence, famous relation of E equals to mc square given by Einstein. Now what is the significance of mass energy equivalence E equals to mc square equation? Significance is, it is an universal equivalence between mass and energy. This means the mass can be created or destroyed if an equivalent amount of energy is vanished or created, and vice versa. এটা হচ্ছে একটা ইউনিভার্সাল ইকুইভ্যালেন্স রিলেশন বিটুইন মাস এবং এনার্জি। যখনই কোনো মাস ক্রিয়েটেড হচ্ছে অথবা ডিস্ট্রয়েড হচ্ছে একটা পার্টিকুলার ইনসিডেন্টে, তাহলে তার ইকুইভ্যালেন্ট অ্যামাউন্ট অফ এনার্জি আইদার ভ্যানিশ করছে অথবা ক্রিয়েটেড হবে, এবং এর উল্টোটাও হচ্ছে ইকুয়ালি সত্যি। তার মানে কোনো মাস ক্রিয়েটেড হলে অথবা ডিস্ট্রয়েড হলে অ্যামাউন্ট অফ এনার্জি ভ্যানিশ করবে অথবা ক্রিয়েটেড হবে, অর কোনো এনার্জি অ্যামাউন্ট অফ এনার্জি যদি ভ্যানিশ করে অর ক্রিয়েটেড হয় তাহলে ইকুইভ্যালেন্ট অ্যামাউন্ট অফ মাস ক্রিয়েটেড হবে অথবা ডিস্ট্রয়েড হবে। এটা হচ্ছে দ্যাট ফেমাস মাস এনার্জি ইকুইভ্যালেন্স E equals to mc square এর সিগনিফিক্যান্স। নেক্সট we will discuss about relativistic energy momentum relation or relativistic dispersion relation. The relativistic equation relating energy and momentum for a particular mass of rest mass m0 is given by this equation. E square equals to p square c square plus m0 square c to the power 4. This is the relativistic dispersion relation or relativistic energy momentum relation. This proof is not in your syllabus. So for information we just have to know this. Here E is total energy of the object. P is relativistic momentum. So this is relativistic momentum. And m0, as we know, rest mass of electron, rest mass of the object. And c is velocity of light in free space or speed of light in free space. So this is the energy momentum dispersion relation for relativistic case. E square equals to p square c square plus m naught square c to the power 4. Now what happens when the object is massless? As we know, the relativistic energy momentum dispersion relation is E square equals to p square c square plus m naught square c to the power 4. Object is massless means m naught equals to 0. So this term will be 0 and consequently E square would be p square c square or E equals to p into c. So energy of the particular object which is massless becomes momentum into relativistic momentum into speed of light. Now what are the such and what is such example? Say particle has momentum but it has mass 0 or which is massless but has a momentum. Example is photon which is massless but has momentum. Massless particle but having momentum, which is photon. So for photon, total energy would be P into C. Now the case 2, when object speed is very less than the speed of light in free space. That means U very small compared to C. So object speed very small compared to C means it is Newtonian mechanics. That means non-relativistic case. So which is Newtonian mechanics. Non-relativistic mechanics. So our starting equation would be same, that is relativistic case E square equals to p square c square plus m naught square c to the power 4, which would be equals to p square means m into u square c square plus m naught square c to the power 4. Secondly, m means relativistic mass, which is m naught divided by root under 1 minus u square by c square whole square into u square c square plus m naught square c to the power 4. Now, as velocity or speed of the object is very less than c, then u by c would be very less than 1, or u square by c square would be very less than 1 or negligible. So E square, in that case this term will be negligible. That means it would be very less than 1 or will be almost 0 or negligible. So E square would be m square, m naught square, u square, c square plus m naught square c to the power 4. Or if we take common m naught square c to the power 4 common, in bracket it will be u square by c square plus 1, or E would be square root of right hand side, so it would be m naught c square into 1 plus u square by c square to the power half, or if we expand it then we will get m naught c square, in bracket we will get 1 plus half into u square by c square plus u to the power 4 by c to the power 4. Sorry, as u by c is very less than 1, then this higher term will be negligible. So we get E equals to m0 c square 1 plus half u square by c square, or equals to m0 c square plus half m0 U square. So total energy would be equals to, this is rest mass energy plus this one is classical kinetic energy, or this is classical mechanics kinetic energy. So whenever the velocity of the object becomes very less than speed of light, then total energy becomes rest mass energy plus classical kinetic energy of that particular object. So this is the second case. Next, third case, when object is at rest, that means U equals to 0. So what we get is, starting equation is same, square is equals to p square c square plus m naught square c to the power 4. So as U 0, so this contains U, so this p will also be 0. So total energy would be just m0 square c to the power 4. Total energy square would be m0 square c to the power 4, or E would be only m0 or m0 c square, which is equals to rest mass energy. So when object is at rest, total energy would be rest mass energy only. So this is the end of today's lecture. In the next video, I will continue from here. Don't forget to subscribe the channel. See you in the next video. Till then, bye.